Meet NAURA. She thinks she is about to have the perfect breakfast. She's got her toast, her mayonnaise, her favourite chips, completely unaware that her morning is about to be chemically ruined. Boom! A sudden scientific anomaly has instantly vaporized every single synthetic food additive on planet Earth.
This cannot be
Let
happening.
us observe the immediate, tragic consequences of a world without chemical preservation. NAURA goes for the toast. But wait! Total mold takeover in 3, 2, 1. Without synthetic preservatives to inhibit fungal enzymes, bacterial and mold spores have claimed the bread as their new sovereign territory. Desperate for calories, she reaches for the mayonnaise. But look at that jar. Without emulsifiers to bridge the gap between polar water and non-polar oil molecules, they have mutually decided to end their relationship. It is a messy, unspreadable breakup. In a final act of desperation, she opens the potato chips. Oh dear. Without antioxidants to sacrifice themselves to incoming oxygen, rapid lipid oxidation has taken place. The fats have broken down into smelly aldehydes and, yep, she has fainted. Rest in peace, breakfast. Now that we have witnessed the chaotic breakfast apocalypse, let us step into the laboratory and look at the actual chemistry. Why did our food turn against us? Food additives are not just random chemical fillers. They are highly specialized molecular bodyguards designed to interfere with natural decay, chemical degradation, and oxidation pathways. Let's dissect the molecular mechanics of the Big Four. First up, preservatives. When we look at chemical preservatives like sodium benzoate, their primary objective is to target microbial cell membranes. Once they cross the lipid bilayer of fungi or bacteria, they dissociate, raising the internal concentration of hydrogen ions and lowering the cell's internal pH. This sudden acidification denatures crucial cellular enzymes, completely shutting down the microbes' metabolic pathways and halting replication. No replication, no mold, keeping your bread pristine. But what about the mayonnaise tragedy? Oil and water naturally separate due to differences in polarity. Water is highly polar and forms strong hydrogen bonds, while oil is nonpolar and hydrophobic. Emulsifiers act as molecular peacekeepers. They are amphiphilic molecules possessing a highly polar hydrophilic head that easily bonds with water and a long, non-polar lipophilic hydrocarbon tail that dissolves in lipids. By aligning at the oil-water interface, they reduce interfacial tension, holding the mixture in a stable, unified emulsion. And what about the stinky chips? That is oxidation. Left alone, atmospheric oxygen attacks the unsaturated fats in food, breaking them down into smelly compounds. But antioxidants are heroes. They willingly sacrifice themselves by reacting with oxygen first, keeping your snacks crunchy. This entire situation highlights a fundamental pillar of scientific inquiry, the tentative nature of science. Scientific knowledge is never static. In the 20th century, synthetic additives were hailed as the peak of food safety. However, as modern analytical techniques improve, new epidemiological data reveals potential long-term risks. Because science constantly self-corrects, today's chemical trends are shifting away from synthetic molecules toward biocompatible, natural alternatives, which brings us to our groundbreaking entrepreneurial solution. So, how do we solve this massive food preservation crisis without continuously injecting synthetic chemicals directly into what we eat? Why don't we just use the wonders of the natural world? Let's talk business. Our local night market vendors and neighborhood bakeries face an immense struggle with food waste. Fresh products spoil rapidly, causing high financial losses. Yet health-conscious modern consumers are actively rejecting harsh artificial additives. It is an expensive, frustrating dilemma. But what if we could protect food naturally and interactively? Introducing ChromaShield, the world's first intelligent active food wrap. Instead of chemically altering the food itself, we have engineered an eco-friendly, biodegradable polymer film infused with natural pH-sensitive anthocyanin pigments extracted straight from red cabbage, stabilized with a mild alkaline agent to achieve a beautiful, natural teal color. This isn't just a physical barrier, it's a smart biochemical shield. ChromaShield works on two crucial fronts. First, the natural antioxidant compounds embedded within the film actively scavenge atmospheric oxygen, halting lipid oxidation in its tracks to prevent rancidity. Second, and most impressively, it acts as a visual pH sensor. As spoilage bacteria grow on food, they release acidic byproducts. The moment the local microenvironment acidifies, the anthocyanins chemically react, causing the wrap to smoothly transition from teal to a vivid, unmistakable bright pink. It literally warns vendors and consumers that spoilage has begun before any foul odors or mold even develop. It is a highly scalable, value-driven solution designed to slash waste, secure food safety, and protect profit margins for our local vendors. Science is not just about memorizing formulas in a textbook. It is about taking those chemical principles and innovating real-world solutions for a better society. Don't let your next meal turn into a terrifying chemical disaster.